And that is it. We are live. I'm really excited to be talking with you all and bringing on a guest that I met on LinkedIn, David Knickerbocker. He's been in the data world for a lot longer than I have and has a wealth of experience that is just really fun to hear about. We are streaming currently on LinkedIn, YouTube, and my Facebook page. We're going to be sending out a link to anybody who may be signed up for the LinkedIn event. So if you're having troubles finding that, which you wouldn't hear that if you weren't already in the stream, so I guess it doesn't make sense to mention that. But anyway, David Knickerbocker is the guest on the Lead with Data podcast that we have today, and I'll give him a quick chance to introduce himself. Hey, David.
Hey, everybody. So my name is David Knickerbocker. I've been writing code since I was 6 years old. I've been working with databases since I was a teenager. So this stuff is just my whole life at this point. I started my career a long time ago as a web developer around 1999. So this was back before websites had databases tied to most of them. So I got to experience a lot of really cool stuff from that, from seeing the first SQL injection attacks to creating dynamic websites to all kinds of cool stuff. And then from there, I became a database engineer, SQL developer, database administrator at some point, then a data operations engineer, and now I'm a data engineer. And I dabble a lot with data science and networks and things like that, NLP and ML and stuff like that. So I'm kind of all over the place, but to me, it's natural. It just all ties together. It's just data, and I've been doing data for so long that it's just another thing. So,
yeah, you've really touched pretty much every area, it sounds, of the data profession, if you will. And we actually originally got connected on LinkedIn because I saw a number of your posts. I think it was the hashtag 100 days of NLP when I first started seeing your posts. So that's natural language processing. And then you have since moved on to 100 days of networks. How did you get started in just kind of challenging yourself in a very public way of sharing the things that you're looking into and learning?
Sure. Yeah. I got into networks. I actually first stumbled into networks because I went through the Coursera courses from the University of Michigan on data science. I found them really well done. Really helped me get my head around Python and that side of things. Before that, I was not a Python developer. I've worked with many languages in the past. I actually hated Python for a long time. I thought it was an abomination of a language because, no brackets and other reasons. But I eventually learned to love Python. But during those courses, they had one on social network analysis. And my first reaction was, why do I want to study Facebook? It sounds terrible, but I'm going to take the class anyway. But it was really all about complex network analysis. It was all about network analysis. And so for the first time, I was hearing about centralities and degrees and nodes and edges and attacking networks to break them into pieces. And I'm a security guy, so I like to think about attacking and defending, knowing two sides of that coin. So there's a lot of really cool stuff that you can do with networks. But why did I decide to start those challenges? NLP was one area that I just couldn't quite wrap my head around. I've been familiar with ML before that for a couple of years, but the NLP side of things is a little bit different because you're taking a string of human text, and now I know how you do it. You break it up with TF-IDF and you feed it to whatever, and it's just a big process. But back then I just couldn't make sense of it. And so I thought, what better way to learn something than to really dedicate yourself to learning something? And if you want to learn anything from gardening to anything, 100 days is quite an amount of time to do it. And so when I said 100 days, it really was 100 posts. It probably was 200 days, because a lot of evenings were reading, and not writing code immediately after. Like you have to spend some time in the books to actually get things to make sense. So it was really 100 posts of cool stuff that I'm doing, but probably more realistically, it was a couple hundred days. It took most of the year. And then nowadays I'm doing 100 days of networks. I see networks in everything. I work in data operations still to this day, as well as being a data engineer. And so mapping data flow is very important. And networks are a natural way to do that. So when you map out a data flow in a network, you can actually see, what are the most critical pieces in a data center? What's the most important server out of 12 of them? Or what's the most important script on a server that if it breaks, everything else goes down? Networks are just, they just really tie everything together, which is what networks do anyway. So yeah, I just decided that these were two areas that I feel could really change my own person as a software developer if I really, really knew it. And it's true. It's helping out so much with all my work, including as a data engineer. So
yeah. Oh man, there's so much good stuff in that description that you gave that I got to pick something to start off with. I love your description of if you want to learn anything, whether it's gardening or something technical, there's got to be a passion behind it, right? Like, I can't tell you how many times I've come across some cool technology or some new hobby or area of interest where you can hop online now, go to YouTube, and just start watching videos on it and, thinking in your brain about all of these things that you could do with it. But until you sit down and actually start writing that code or having some sort of end project that's not like, I ran through the tutorial that pretty much gave me the code and I copy pasted the code and ran it, right? Like, that stuff doesn't stick in your brain, and then you aren't able to build on top of that skill set. So once you have that passionate thing that you can chase after that's unique to you and meaningful to you, you just get so much more out of that.
yeah, absolutely. And this is something that I've always taught. Like back when I was a web developer 20 years ago, people would come to me, asking how to get started. And there's a couple of different ways that software is taught. When you're in college, your professors tell you to create a calculator, something completely boring that you don't care about whatsoever. And so I understand that the point is to get you to understand, if statements or cases, and to understand process flow and things like that. But it's so freaking boring that I think, well, I know myself, when I took my first C++ college class in 1997 or 8, I left it hating programming. And I wrote my first code when I was 6 years old. So I went to college long after that, and so I've been writing code, but my first programming class actually made me hate programming. And so now looking back, I know that was a terrible professor. He just wasn't able to get your attention, couldn't get you to love, and so you didn't make it personal. And at the same time, like I've taught both of my daughters programming, and they're both children, and I taught them as soon as they learned how to read. And I do it by making it like, you don't have to teach teenagers, which are what college kids are when they first go to college. You don't have to make them make a calculator. My daughters would make like a Mad Libs program, and they would have hours and hours of fun, and that would teach them variables. And if you want to make it more interesting, you could have a while loop or something like that to flip through, to randomly flip through different Mad Libs, and
yeah,
there's just a lot more that you can teach when you turn it into a game if you can't make it into something that you're passionate about, And so we're adults. We know what we're passionate about. And so like I often use the book of Alice in Wonderland for my NLP experiments because I love Alice in Wonderland and I can remember the story quite well. And that's really helped me out with my network learning as well. Like the post I did yesterday where I talked about transitivity and previous posts with centralities and things like that. Things made more sense because I had the knowledge of how Alice in Wonderland worked. And so when I got the scores yesterday, the values for um,
Yeah, we're
wow.
actually able to bring stuff up in case if you have those images that would help to explain some of this stuff. We can pull up your shared screen if you want to, but yeah,
Yeah,
I absolutely love that, especially the tie into to literature, right? Like as you were discussing this, you learned to code, and the way it was taught made you lose this passion for coding. That made me think about reading. As a kid, I loved to read, but as soon as I got into these reading programs in like middle school and high school, where you get some sort of reward for reading a certain number of books and writing the report, I stopped reading as soon as those programs were done, right?
yeah,
Because I was reading things I wasn't really interested in to do some sort of gamified, make sure your
yeah,
kids are reading program. Yeah, so
yeah.
I think a lot of times the STEM fields end up getting considered very separately from the arts, including literature. And I just love that you're bringing those kind of back together because you have an interest in both of them. There's no reason why they shouldn't be able to be linked.
Yeah, when I was in college, I was actually taking literature courses at the same time as computer science courses because they kept my sanity. I loved reading
Mm,
as much as I could. I loved taking war literature classes, or um, I love books like 1984 or Brave New World, stuff like that. Uh, kind of the dark side of things.
yeah,
And so that's always going to be a part of me. And so I love NLP because it kind of allows me to be a programmer, but also to explore the arts again. And machine learning is going to really be a big part with, what you can do with painting and pictures and audio and things like that as well. And so this is a really, really cool time to be a developer because we actually have the tools available to us to explore these passions that we have inside of us that have kind of maybe been allowed to fizzle out over the years. Like I still consider myself a bit of a musician and I like to write. But we all kind of put our dreams to the side a little bit, I think, when we become professionals. And sometimes we never get that back. Um,
yeah,
but as I get to explore networks and natural language processing and ML and data science and stuff like that, I'm fully back into it. If I wanted to redo this analysis with the book 1984 or the Bible or anything, or a bunch of speeches by anybody, I could, and so
yeah.
it's fascinating stuff because um, you actually get to explore the things that are interesting to you instead of creating a calculator or instead of creating
Yeah,
a ML model that can detect different kinds of orchids or whatever.
right. Oh yeah, classic or handwritten letters,
Yeah,
which or numbers, which minced. It's
yeah,
might be useful, but probably not. We're
yeah.
we're getting a couple of comments. It's a little bit delayed, and usually it tells me who the person is. So I don't know if LinkedIn's got some weird issue, but apparently we have another fan of Alice in Wonderland and the complex linguistics involved. And then also a comment about fractals in uh, data analysis. And you asked, so I'm guessing maybe you've got some context for this, but have you used fractals
No,
in any of your data analysis?
I have a friend that I hang out with, and he brings that up all the time. And I don't know how to answer that question, but I recently read this book, and so this is something I'd like to read
Chaos.
and see what can be done. I feel like I saw something recently that did mention use of fractals in data analysis, but it's not something I've explored yet. Uh, so
Okay.
I
I've
don't have.
been wanting myself to get into fractals ever since I got introduced to the author Nassim Taleb. I don't know if you've read any of his stuff. He's the Black Swan, Risk, all that type of stuff, and he's got this mathematical foundation from trading stock options on how you can use those as a mathematical model to
Mhm,
prevent yourself from underestimating risk, right?
mhm.
And there was so many cool applications of fractals once I dove into what that could be used for. But again, I didn't have that passionate project that I was like, this is what I'm gonna use to learn fractals or use this analysis. So
Yeah,
maybe if I can find that.
I told my buddy that he's starting college to pursue data science, and so I'm really excited
Yeah.
by his passion. He's heard me talking about ML for ever for a while,
Yeah.
you know, and just talking about data and all the cool stuff that I build, and he just kind of got hooked onto that, and so yeah, he's just starting college to pursue an education in data science, and he's very much into fractals, and so he likes to talk about it, but it's just something that I haven't read about to I can
Yeah.
get an answer on it yet. So, but I
Yeah.
did buy a couple of books on complexity and chaos. So, these look good, but I spend most of my time reading programming books and NLP books and less of the just nonfiction. It's a jump to go back to it.
Right.
So they look good, but I just haven't had time to read them yet.
Yeah. Yeah. So for people who are getting into data science, then, so you mentioned you've got one friend who's going in there, and I've got a sister-in-law who is going back to school for data science. There's all these different tool sets out there, all these different languages. You mentioned Python. That's kind of my most comfortable language. I actually hated it at first too. I was a MATLAB guy before converting. Um, but what sort of advice would you have for people who are wanting to get into data science?
I always tell people to chase their curiosity. And so you have to
Mm,
find something that you're actually curious about, and then find data that has something to do with that. NLP, the world of NLP, actually, it's a bit easier because Twitter is wide open, so you can scrape to your heart's content. You can scrape terabytes of data if you really want on any subject, and or you can just go out and find text and play with that. But if your hobby is, or if the data that you're interested in is much more difficult to find, then that's obviously going to be tricky. But
yeah.
um, and I'm kind of reluctant to answer this question simply because when I first decided to get into ML, my friend asked me, "Why would you want, or what do you want to build?" And my answer to him was, "Whatever I want to build." Like whatever it is that I decide to build tonight. Like it's just that I want to get that. Uh, can you hear me still?
Yeah.
Okay, I thought
Yep.
everything was right. I want to get that skill so that I can chase any curiosity that I have in the middle of reading any book that I'm reading, or watching some documentary, or reading something on the internet. If I decide that there's something new that I want to explore, I can go scrape it, you and so there is value in learning fundamental approaches to things like scraping, or how to even load an Excel file into pandas, or how to load the iris data set and into scikit and do your first classification experiment. um, there's always going to be some stuff that's just boring and tedious. Like cross validation is never interesting, but it's
Yeah.
important, you know. But you have to learn all of that stuff. But the data set is really up to you, and your models don't have to predict at 90% accuracy your first time. If your first model predicts at 60% accuracy, it's still your first model. You did it. You created the first thing, and you can figure out what went wrong. And if your first model creates at 100 or predicts at 100% accuracy, you can figure out what you did wrong. Why it's predicting at 100% accuracy. Um,
Yeah.
but
Something's wrong.
yeah, but most important is to just find the data that you're interested in exploring, and it can be anything. And so for me, some of the data sets that I like to explore are, I love Alice in Wonderland. I'm also doing a lot of scraping for Twitter activity in my local area, because I want to know how crime is doing in Portland. And so I scrape like
uh,
the Portland police, rather than scraping. I tried to scrape all of the media outlets, but that didn't turn into a good exercise because one murder could get 6 articles by the same news agency. You know,
uh,
Whereas the police don't deal in sensationalism as much, and they'll just say shots fired on this street, and that's,
yeah.
and so it's much easier to create like a violence classifier off of police activity than it is off of media. All you'll get is a count of how many times something violent was mentioned.
Yeah.
You know,
That's such a good point. Like whenever I've encouraged people in their initial foray into the data world, I've usually advocated for using Python to do web scraping. And like you say, Twitter's such a great repository of ever changing information.
Yep.
But the reason why I do that is because the data ends up being so dirty compared to these nice canned data sets, right? And
Yep.
I think what you just described there is a really good example of a very common problem when you're trying to make these machine learning models or other classifiers on these data sets, which is imbalance, or just the whole process of how data gets collected can influence the types of results you get. And
Yep.
so it's not just a matter of having a data set and going through and making something interesting. That whole process can be a learning experience. There's all different components that you can get involved with in it. You don't have to be doing the model bit of it. There's a ton of value that comes in just cleaning the data, because good data is really hard to come by.
Yeah, and I really think that you pick up so much natural learning from playing around with the data. You get to see the problems in the data. You get to see the patterns that you maybe you expect something to be in there that isn't in there. And so I think that some of what I described is actually my data operations and then data engineering side of things coming out when I talk about ML or any kind of data science. Because, for instance, let's say in a high activity time, the server that should be creating the data is crashing. You may never get the high volume traffic to do the analysis against, So if you're having a data flow problem, that's going to manifest or not manifest. You might not see it at all, And so it's important to get the data, to play around with the data, to question if upstream is okay or if there's any problems with the upstream. You need to understand the whole process, So
Yeah,
yeah.
and I found in the projects that I worked on, I spend a lot more time on the data cleaning and exploratory data analysis than I ever expected before getting into this field. Because a lot of times when you learn this stuff, you're given these data sets and you're not really getting to the domain specific knowledge of the problem set that you're dealing with, right? Like these tools, whether it's Python, TensorFlow, R, all these different things that we use to do our analysis. That stuff, very helpful tools, but not the end all be all. They're not the thing that you end up spending most of your time debating, learning, and all of that. It's trying to take these tools and apply them to different domains where if you spend time in the automotive industry applying data science techniques, you're going to end up learning a lot of things about the types of data you get from the automotive industry that makes that really helpful. And for you, security, and for others in my network, logistics, right?
Mhm.
So there's all these different things in these different industries that present their own problems
Yeah.
that end up being the thing that you spend most of your time learning. So,
Yeah.
oh yeah, that's a great point from you,
I think
David.
the best learning really comes from the tedious work, getting dirty with the data. That's really where you build the domain knowledge, not from running .fit. You have to play with the data. You have to know how it comes through. I'm working on something for work right now, and it's using very, very old data, a very old format, and it's mangled. And so you have to know that it's mangled. You have to know how to correct it. You have to know why it's breaking the old thing, and if the new thing can handle it. So I feel like you learn the most from the most tedious and most difficult stuff, and that's kind of applicable to life too. Some of the stuff that has really shaped us comes from the stuff that we probably didn't really want to experience, but that's where the most important learning comes from. I've got so many horror stories from the last 20 years.
Yeah, anyone in particular that's popping into your head from this?
Uh, One of my horror stories.
Yeah,
Yeah, yeah,
stories are always great.
yeah. I grew up on a tropical island, and so there were not many programmers around. I was the only American programmer I knew there. But that also gave me a lot of competitive advantage. Like I
Yeah.
did freelance.
Are you saying that programmers and nice outdoor tropical environments don't mix?
It was just a tiny little island, and
Okay.
there was a big U.S. military presence, but there was almost nobody like me who was American, not in the military. I grew up. My parents were military contractors, and so I grew up there. And I went back there after college, and I did the whole living in Japan as a foreigner, not on the military base. And so I immersed myself into the culture and all of that. And so when I came back as an adult, I realized that Americans were still putting their cars for sale up on thumbtack boards, and I was like, this is ridiculous. And so I created the island's first classifieds website, and immediately it blew up. And for when I first built that classifieds website, I built their database, and I was like 20 years old, so this is forgivable. But I created a timestamp as the primary key because we got ads. We didn't get an ad every single millisecond. They were spaced out, and so a timestamp, a MySQL timestamp, actually worked okay. And I one day decided I wanted to change it to an integer for auto increment, and just that was a more natural thing to do. And so I did that, and I didn't think through the repercussions of doing that. But when I did that, when I created the new primary key, there was an auto integer. It changed all the timestamps to be the equal timestamp on the entire table. And right before doing that change to the table, somebody asked me to update their ad. And so one, I changed the primary key from a timestamp to an auto increment. And then two, I ran an update on an ad against the timestamp and updated the entire table. Overwrote every single person's ad in that table.
Oh no.
And this was one of the first days of that thing. And so we just wiped and started over and apologized. This is pretty green stuff,
Yeah.
you have to forgive us. And so everybody was fine. They just uploaded their ad. It was like 100 characters, about as serious as a Twitter post, not that big of
Yeah.
but it was something that really spooked me because I didn't. It's not like I dropped the table, but it had the same effect, and so it was sneaky. Just how silently you could destroy an entire table of data, And so now I work with databases that have billions of rows of data in them, Like I can't imagine if I corrupted data in a database with 300 billion rows or something like that. That would just be a massive catastrophe, and a rollback would be insane. And so I'm glad I learned that lesson on a table when I was 20 years old that maybe had 600 rows of data in it instead of 100 billion,
Yeah, I always ask for read-only keys to start with as I do my exploratory stuff because, yeah, I am terrified of doing something on a large scale like that one day, of messing up and being like, well, that sucked.
And everything was very much wild, wild west development on the island. Like I was typically the only programmer at the company. I had no support. I had no DBA. I had no database engineers. At one company, I did anything involving code, and they didn't have a marketing person, so I decided I was going to be their marketing person as well. And so I was, I'm wearing every hat that I could potentially wear just to help this company go from nothing to actually being something. There's like 5 of us maybe working at the company at the time, so we were all doing whatever we needed to do. But yeah, now I work for bigger companies, and we have DBAs, and we have DevOps, and we have security people, and we have everybody is something different, and that's kind of a weird feeling to me, having grown up on a small island where I had to do everything. Now I'm always tempted to do everything because I know how to do everything to a degree, there's power in that, because I can do an entire proof of concept by myself very, very quickly. But it's also very useful to rely on people that only do databases, to warn you against doing something catastrophic like I did. The world is much more segmented. Thank you
Yeah.
for that comment. Yeah, that's I'll never forget that, and that was one of my first experiences in my career. But I'll never forget that. That's how much of an impact it made.
Yeah, we have a not really a question, but maybe more of a implication or whatnot. Did you have slow internet on the island, or was this relatively zippy for you to be able to manage a website like that?
In Japan actually has really fast internet, and we had fiber like long ago.
Oh man.
So I don't even think my internet right now is as fast as it ever was in Japan. So
Yeah, I mean today that's I've been wishing for fiber optic to come to my area, but I've switched over to a business grade connection because of some of the streaming stuff and reliability and all of that. But yeah, when you work in data, not having a good internet connection now can really hamper your ability to do your work, especially when we're all working remotely,
yep.
or a
Is
lot of us are. I don't know. Are you working remotely right
Yeah,
now?
I've been working remote for a few years though. But is my internet connection okay right now, or is it choppy at all?
Yeah, you seem to be coming in through clear to me.
Okay.
At least I can hear you. I don't know if anybody can let us know in the comments how it's coming through, but there's been a few that I see that things are going well. So
Okay.
yeah.
But yeah, I've been working remote really a lot of my career. Like even 20 years ago, I mean, I was web developer back then, and so my work was on a web server, which is it's remote work. You know, I would SSH to it or
Yeah.
FTP to it, just like I do nowadays. I mean, nowadays I SSH to whatever I have to or VPN in. But there's not very much difference. So I was getting used to remote work in the early 2000s. Really, I was working fully from home, like in 2001. The company I worked for at the time split in half, and the side that chose me, well, I asked them, "Can I work from home?" And they said yes, and that's why I went with them. So I've been working from home forever, and I just like it. I do like going to the office, and I like sitting down and having ice cream in the cafeteria and stuff like that. You know, when we had that. Um, so I really do miss going to the office, and it's much easier to draw pictures on a whiteboard and explain ideas uh,
Oh
than
yeah.
than on a Zoom call or something like that. So there is a dynamic that I definitely miss. But my boss is not even in the USA. None of my teammates are in the same states as I am. So I'm just completely used to collaborating with people like we are right now. Like
Yeah.
this is what my everyday looks like. So
Yeah. So, I mean, one of the things with being able to work remotely, and I would say a lot of jobs being data jobs, that being just sort of a natural fit, is uh, when I started looking at jobs in the data field, all the big names like Google and Microsoft and all these Facebook, those would be like the dream jobs for people who are recently graduating. And with all of the effort that they put into these massive models and cutting edge technology, I almost had the impression that that's the only place that you could do data science and machine learning because they were the ones with access to data.
yeah,
And I think one of the things that we've been talking about pretty consistently on this stream is that data is out there, especially on Twitter, but with Wikipedia and on the internet, that you know, there's an opportunity even in small business with business level data like marketing and advertising and even probably the accounting side of stuff to be able to make an impact. And so, if you have a passion in an area, there's not a need necessarily to go to large companies,
no, not at all.
but you could pretty much live wherever you want now and work for a large or a small company. It's just, again, kind of what you're passionate about.
Yeah, and that there's if you follow some of my adventures on LinkedIn, I tend to stick to simpler models, not use neural networks, things like that. I keep things as simple as possible to show that you can do really amazing things and still keep it very simple. You don't need a neural network for everything. You don't need a terabyte of training data. Uh, for
Yeah.
most NLP things, you really like if I were to create a classifier right now to detect hate speech, I could build it off of 4,000 rows of data. Like you don't need a
Mm.
million rows of data. You just need examples for it to learn from. And it might not be a perfect model, and a convolutional neural network might do it better, might do it 2% better, but I don't need that 2%, and so one of my dreams, and I don't know if it's ever going to happen, is that I would like to find a way to actually help smaller to mid-sized companies, because I think that a lot of people are intimidated by the large companies, because you always hear about the Facebooks and the Intels and the Microsofts and the IBMs and all this cool stuff that these big guys are doing. But screw that. We can do cool stuff with tiny amounts of data if you just allow yourself to explore it, and you allow yourself to realize that you don't have to build things as complicated as they are, and a model that can predict at 85% accuracy for cheap is, in my opinion, as valuable to me as or more valuable to me
Yeah.
a model that I'm going to have to rack up a $1,000 AWS bill every month for, like I can
Yeah.
run.
You could. So yeah, you could put together that whole project and deploy it on a website and have your product done in the weeks that it would take for these
Yeah,
large companies to just train up their massive GPT-3 model, right?
exactly. Yeah.
Like,
There's a post I saw recently that was saying that AWS is not cheap. To create a model, you have to have a server that has this specs, and it's going to cost you $100,000 a year, and that's crap. I have my own T2 Micro, so like the smallest that you can possibly get, and it's running 5 NLP models on it 24/7. And this is a tiny, tiny server. And I deployed it. I managed like four very old ML servers at the company where I worked for. And so I've seen the old way of deploying ML code, and I kind of follow that model because I'm not super sophisticated. I just keep things simple. But I've got these models running on a T2 micro, and my bill is like $50 a month. But that server is doing way more than just that NLP stuff. I've got it running scraping all the time.
oh
I've got
man.
another server I'm using. I've got SageMaker going every now and then. And so you don't need to spend $100,000 to get into ML. Like a small company could get into ML or NLP for dirt cheap. And people should realize that. They need to know that, But if you only follow what's going on LinkedIn, you get the impression that you have to have the most state of the art. And you really don't.
Yeah.
Random forest is still wicked. You can so it's still outstanding, and LDA is outstanding for NLP and naive Bayes as well.
Oh
So
yeah.
you don't need a neural network for everything. And I say that so many times.
Yeah, there's so one of the projects I've worked on in the past was robotic vacuums, right? And helping come up with some algorithms from some low cost sensors because it's a consumer product and have it make decisions on whether to follow a wall or make a turn here and there. And the best performing thing that we did was decision trees, right?
Mhm.
Like a couple of those put together in a sort of ensemble because in the end, you're on an embedded platform, so you really can't train up a massive model for it. But some of these tools, like you said, are, I mean, the basic ones, they're still extremely powerful. And when you have either limited resources, either on your end product, or limited resources in your ability to develop because you're a startup or you're just getting into this and you don't want to drop $1,000 on a graphics card for your GPU and then all the other components, uh, you can do so much with so little. And especially since the main thing is good data,
Yep.
that bit is practically free. If
Yep.
you know where to look around on the internet and see if you can find something that interests you. Oh, I
Yep.
love that.
Yeah, like the models that I did end up deploying, they can run on my Microsoft Surface laptop. I don't have a big PC with a ton of RAM in it at home. I do things as cheap as possible, as light as possible, and to show that it can work. And so I know that there are bigger and better ways to do things, but I'm one person. And if I'm trying to solve a data problem, I don't need the most complicated way to do things. You can do things cheap. So I really hope that that message spreads, um,
Yeah.
because I was intimidated when I first got into this field. I thought I wasn't smart enough. I thought that there's just so many things in data science that are intimidating. There's so many PhDs running around. There's so much talk about neural networks. There's so many network diagrams of these complicated neural networks, with many, many layers, deep learning and blah, blah. Um, and so there's a lot to be intimidated by, and there's so much imposter syndrome all the time. Like, you'll never outgrow that, because there's just always something to learn, and there's always something to feel bad that you don't know about, or that you
Right.
don't know enough about, like fractals, for instance. And so I'm going to have to read that. There's always something that you don't know, and there's always somebody that that knows it better than you, and so you're always going to be having these confidence issues all the time, and that's just natural for this field. But also, like, my my areas of expertise are, web development and security and data related stuff, and so I have to read books on programming all the time, and security all the time, and data science all the time. And so one of these domains by itself is a lot of room to cover. And if I focus entirely on data science, then I'm neglecting security, and so the next year I have to play a whole ton of catch up, you know. And so the data world is just overwhelming, but I think I have kind of gone from being intimidated by it to like absorbing the energy from it. Like, I just, it drives me now, and it's not about doing something novel just to do something new. Uh, it's that the tools that I'm learning from these books and from writing the code myself allow me to see the world in a way that I never saw before. And I'm 42 years old, and so I'm a 42-year-old, and I feel like I'm a kid again, finding a brand
That's
new
awesome.
world, a brand new way to experience the world. Like, this network stuff has allowed me to see what is the primary cliche or click in Alice in Wonderland, and out of the primary click, using local clustering coefficients, you can see who are the actual drivers in that click, and it's Alice and the Queen of Hearts and somebody else right after that. And so the
Yeah.
behind network science allows you to find things that you realized yourself, or you were taught in college or whatever, and it does it, and it's fascinating, and it's just new tools to explore the world in a different way, much, much faster.
Yeah.
So
Do you, we were just talking about this, I think, last night. Do you have that image that we could pull up?
yeah, if
Because
you
I
give me
thought that was just such a cool visual. And while you bring that up, I love that sentiment of because of this whole going from intimidation, almost like fear of getting into this type of work, to getting energy from it
yep.
and inspiration. Because I had a very similar process going through this when I left the university. In university, you can do all these canned problems. There's a right answer. You kind of apply your skills very broadly. But then once you're in industry, you almost start to niche down because of, the specific domain that you get dropped in. And I've always had this fear that once I was going to start in industry, I would end up picking up a skill set that I continued to niche down into, and maybe I picked the wrong one,
Yeah.
right? And what I found with data professional jobs is that the tool sets that you're learning are so broadly applicable.
Hmm.
And it's still, I mean, it's been around for a while, the techniques to process data, but it still feels like it's nascent, right?
Yeah.
And so, instead of, for people who are getting into this, instead of feeling fear about how much is out there, just coming to that acceptance that you aren't going to learn it all
Hmm.
can help you get to a point where it turns into that energy generating and that sort of inspiration of, you can find whatever crazy niche you want out of your passions and be an expert in that domain, whether
Yep.
you're an expert in the tool set or the programming language or whatever, that's available to you.
Yep. And
So,
I've found that there really are no experts in everything in this field. Like, uh,
mm,
yeah, I like that comment.
yeah.
It's got to be passionate. It's got to be meaningful to you. Like if I have to, and like the hardest work that I have to do is when I have to analyze data that I just don't care about, or I have to fix a problem that I just don't care about, or when I know that there's a newer approach that can be done much easier, and I still have
Mm,
to do it the old approach. Like, we don't always get to choose what we want to do. We have managers that tell us what to do, and so there's always going to be some work that's just tedious and dry. But when you are suffering through work that you don't like, that's when it's time to work on your personal projects at home also.
uh,
That allows you to kind of keep exploring the thing that you want to do, even when you're getting paid to do something mind-numbingly dull. And like I said earlier, the hardest stuff, the stuff that you don't really want to do, often ends up being the most important stuff that you learned. Uh, so it's all valuable. You just gotta kind of balance your exploration. But give me a second, and I'll try to pull up that network picture real quick.
yeah, I think it's at the bottom of the StreamYard portal here. There's an option to share the screen. But
Okay,
I also imagine it's buried somewhere in all of the plots that you've come up in your time analyzing that book.
that's cool. I can see my stuff on LinkedIn right now. All right, give
Yeah,
me
I'm really interested in learning from you in your 100 days of networks hashtag because through doing streaming like this, it's really cool. I stream to YouTube and it generates captions for me and allows me to download those captions. So I've been able to collect, I would say, hours and hours of conversations like this. And I think it would be really cool to take that text caption data from all these hours of conversations and, basic stuff like making word clouds out of them to just kind of see how that turns out. But starting to link topics together and seeing, whether the comments that come up or the general themes that seem to be consistent between them. Uh, there's just always interesting things that happen when you take a data set. You have no idea what could come out of it. And just with a little bit of playing around, patterns start to emerge.
Yeah, definitely. I'd love to help you if you ever need it. Um, Let me know when you can see my screen.
Yep.
Can you
So,
can you see my screen right now?
yep. Oh, we're meta now. We're in two places. There
Yeah.
we go.
All right, so you can see that graph visualization.
Yep.
All right. So
Yeah.
this is the entire social network in the Alice in Wonderland book. I created this during 100 days of NLP by using pause tagging, part of speech tagging, and then building a network. And I really think that I should probably actually export this network to CSV so that other people can use it, because it's just so much fun of a network to play with. It's not too big. It's kind of like Goldilocks, it's
Yeah.
a small network. It allows you to dig around and see centralities and shortest paths and things like that. But yeah, this is the network in Alice in Wonderland. And so yesterday I was learning about transitivity, which is the clustering coefficient, and I spelled it wrong in a bunch of places, so forgive me for that.
It's
But,
comments.
but yeah,
I'm
13.
surprised you have comments.
Yeah, sometimes I'll put. I'm just lazy, and I'll just put it in comments so that's easier. But this is the percent of triangles. This is the percent of possible triangles that appear in the network. And so triangles are very important because like if I know, if A knows B and B knows C, then A probably also knows C by association. Wait, A knows B, B knows C. Whatever. Um, and so anyway, this is the key click in the Book of Alice in Wonderland. And so you've got Alice in the middle, Dormouse, Mad Hatter, March Hare, King of Hearts, Queen of Hearts, and Cheshire Cat. And there's also page rank running in the background. And so in this, you can see that Alice is the most central person, which makes sense because the book is about her. But you can use the local clustering coefficient to see the amount of influence that a person or node has on information flow. And so when you look at the local clustering, low scores will mean greater influence. And so for Alice to have the lowest non-zero score, kind of seconds what that page rank showed with the coloring, that she is the most influential person in that network. And Mock Turtle is actually above the Queen of Heart, which makes me want to reread the book again to think about that. Like, why exactly is that? But when I took who is in the core clique and ordered them by the local clustering coefficient, the order of influence I get is Alice, Queen of Hearts, King of Hearts, Mad Hatter, Cheshire Cat, March Hare, which in my opinion is about perfect for the main characters in that book. And there's no magic involved. This is just a network and numbers and algorithms that work. But I feel like it fell upon the perfect description of who the primary characters are, both from the clique approach as well as using the local clustering coefficient to kind of showcase that.
Yeah, I'm so glad you were able to find these visuals, because I think it visually, of course, represents a lot of the stuff that we were talking about, right? Like, this isn't millions of rows of data that you had to collect in order to do something interesting out of, right? Like, we can pretty much see all of the data that you had for this.
Yep.
And what I also think is interesting is somebody who knows the story really well could maybe spend the time and make all of these links sort of like manually, like enter in that data. But this is showing some of the power of NLP is you didn't have any domain knowledge about this book that you integrated into the model. This is literally it just reading through words and figuring out the relationship probably between these proper nouns, right? That then when you get the output, you can rectify that in your brain with what you know of the story and say, does this make sense? And it's so interesting how often when you do that, you end up seeing relationships that have meaningful insights into the real world that weren't pre-programmed, right? Like, that's some of the most inspiring stuff for me about machine learning stuff.
Yeah.
So this is some of your code?
This is nuts because, right here, this is reading the entire book, this line of code right here. And then this is just stripping out the junk, the new lines and blah, blah. But down here, so I do a couple experiments. Here I'm using TF-IDF to show where characters actually fall into the book by chapter. So I broke the book down into chapters, and then I knew which characters I wanted, so I just fed them into it. But you can see which characters are in which part of the book. And so this guy is the Mock Turtle. So if I want to figure out why the Mock Turtle was so influential, I'll want to read chapters 9 and 10, and Mad Hatter is in chapters 11 and 7. And so this is pure NLP. This is all just TF-IDF values. And then down here, and then down here, I'm just doing pause tagging, and I'm looking for NNPs to actually find the characters in it. And so there is some cleanup that I had to do. Because of anything with a capitalized first character gets classified as an NNP. And so that's something to know about. And also there's countries that I didn't care to have in this, or things like waistcoat pocket somehow got there. So there was some cleanup, but that's natural in data. And then I was left with the nodes that I wanted. And so reading it into Network X is as simple as reading the entity. Adding edges for each source and target that I created using NLP. And so this was the very first graph of Alice in Wonderland. But scikit network draws it a lot better. And so my more recent work is much lower, where I'm experimenting with K-cores. K-cores are a good way of finding clicks. And so this is saying, give me every click where the members have at least 4 edges between them and somebody else. And so Cheshire Cat, you can see 1, 2, 3, 4 lines. King of Hearts, 1, 2, 3, 4. And there was somebody in here. Alice has 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6.
Yeah.
So 4 to 6. And so as you relax that, you get a different structure. And so you really just have to experiment and find the one that works for you. But I felt that this one, I've been calling it the principal click. There's probably a better name for it. But these are the principal characters in the book, in my opinion. March Hare, I'm kind of surprised that he's there, but maybe I should read the book again. Maybe NLP found something that I didn't. And so as you relax it, you get a bigger network, and as you get back to 1, you get the whole network. So this is not a super big network. This thing could probably save in a text file of less than a kilobyte. So I'll probably share the edge list of this for others to use.
Yeah, that'd be cool. Yeah, and I love your description of how you're going through this problem, because that was a sort of process that I had to learn that is maybe somewhat similar to software programming, but working with data is kind of a whole different animal, and it's highly iterative, right? Like, you get a data set, you apply some initial analysis or some filtering or what have you to it, and you get some amount of insight out of it, which then fuels the next round of cycling through stuff. Whereas in programming, a lot of times it's like, here are the requirements.
Yeah.
You go through and make the test pass. And yes, that's an iterative process. And I'll never say that coding isn't creative, but exploring data takes a level of artistry that it's not like a hard science, right? And yeah, it's another reason why I love that you're bringing in literature into your passion with data science, because you kind of need that artistry skill set, that curiosity, and the willingness to try something new and potentially fail. Because yeah, I mean, there's a lot of models I've made that are terrible, right?
Yep.
But they led me to some level of insight that you then learn from and apply into the next iteration. Sort of meta machine learning, right? Like human learning. I mean, it's just a natural process to go through. But yeah, it's very different from software development.
I'm with you I've been a programmer long enough that I can say that I feel like traditional software development, it just feels soulless to me. Like you lay out your logic, you create these process diagrams, and then you code it. And it's easy to run tests because you know exactly what your code is supposed to do. And so you can do test-driven development. You can just follow how you do test-driven development, make your cases fail and then make them succeed, and then move on to the next one and forever. Whereas data science, it's much more iterative and exploratory, and it never really stops being exploratory until you're done enough, we have a machine learning competition where I work every year, and the first year that I was in it, I placed second in the company, but I created this model that I'm now ashamed of. Like, it's so I did no feature selection. I read in a book on feature engineering that interactions are useful, and so I multiplied each column by every other column. So I just created a massive ton of columns, and then fed it straight to random forest, and it predicts at like 99.7%. And that's great. And it's not from data leakage. It actually does very, very well. It's overcomplicated. And so last year we had the contest again. I won in the company. And I'm a little bit embarrassed about how I won. I created literally the simplest thing I could possibly do. And some of my previous models that I was building for that competition, I experimented with voting classifiers. Like I created something I called community garden. And
Community guard.
yeah, and so that was my little jab at random forest, because me and my wife used to go for a bunch of walks, and we would walk by the community garden. And so I created a bunch of what I call dumb classifiers. I split, like, this data set was massively imbalanced, and so I chopped it into tiny chunks and made it balanced. And so each classifier would train off of like 5,000 rows of data, and there was like 47 classifiers, all training off of 5,000 rows of data. And in the end, they would cast their votes on this final piece that got passed through. And it did okay, but it was way over engineered. And in the end, I went back to my first notebook that was on some of the feature selection I was doing, and I realized that my very first exploratory model actually had higher accuracy than my over-engineered piece of crap. And so I was like, what the heck did I do? And so I went back to it, and I was like, this is doing outstanding already just from throwing data away. What if I throw some more data away? So I went from over-engineering this piece of garbage to throwing away like 90% of the data. And after throwing away so much data and doing no feature engineering, my model was able to predict with the highest accuracy out of everybody in the competition, including somebody who stood up a neural network and other people who did XGBoost or whatever. And it just shows that sometimes throwing away noise will allow you to create an even better model. And so I work with a lot of people who do ML at my company, and one of the first things I ask them is whether they've gotten rid of as much data as they possibly could have, or if they ask me to take a look at the work that they're doing, the first thing that I'll try to do is throw away data and see if I can boost the scores that way. Because I've seen it so many times now that just chopping and chopping and chopping forever, you end up with something that I've called, in my database administrator days, I called it diamond data, where you just had a pure data set. And as a DBA, I valued it because and less storage. If you're only storing the data that you need to store and you're throwing away 90% of your data, your AWS bill is going to shrink massively. You and your operations guys are going to be so much nicer to you because your database is no longer terabytes, it's gigabytes.
Yeah.
And so you have less operations people, you have less operations headaches, you have simpler models, you don't need as big of a server to run your models, you have lower latency on your predictions. There's incredible value in throwing stuff away and actually pursuing that. And so one thing that
that's such a great insight.
Yeah, I used to hear when I was a database guy, I remember working with one person, and I would ask them what data they need, and they would just say, give me all of the data, and to me, that always felt weird because I was a DBA at the time. Like, what do you need all the data? You should figure out what data you actually need before you run your experiments, like, let me help you out. Let me, and so now if somebody actually told me, give me all the data, I kind of get that, if they haven't even approached feature selection yet. But when I hear about models that literally use all the data, or models that are using millions of features or tens of thousands of features, my first impression is that they haven't done the groundwork to figure out what could actually be thrown away. And it's possible.
Right. Yeah.
And if they actually ended up with that, and if it's an NLP model, if you're doing TF-IDF and you end up with hundreds of thousands of features, as the result of TF-IDF, that's forgivable. That's just natural, but you can use topic modeling to further shrink it down, So no matter what you're doing, there's ways to clean it up. And
yeah. And like data sets they're always so noisy, right? And like, if you need so much data to average out the noise, that would imply that that whole data set can be summarized by a few data points, right?
Mm-hmm.
Like, you don't need a bunch of noise to get information out of data. And yeah, I found one of the biggest challenges in doing what you're talking about is when you get something weird in a data set, right? Like, there's a couple of data points or whatever that don't fit. those are the ones that you always want to look at,
Yeah.
because sometimes they're just really bad noise and the result of bad process, which fixing that ends up doing a lot of really good things because you're fixing stuff up the pipeline, right? But a lot of times, those really weird data points are the ones that really matter,
Mhm.
right? So you take a couple of these really aberrant sort of data points and then sample a few of the normal ones. And now you've got what you're talking about, a much cleaner data set, probably
Yep.
a lot better balanced, that you can do more interesting things with, and without all of the massive compute that's usually thrown at these things.
And so
Because,
when you go from 300 columns, 300 features down to 20 features, I say columns features. It
right,
depends what
yeah,
you talk to every day. Um, when you go from 300 to 20, and your model does even better, if you were to like if you're using random forest and you were to look at your feature importances, immediate insights, looking at feature importances when you only have 20 features to look at, you can immediately see which ones are useful. Or if you're using something like Lime, to I always get explainable AI and interpretable AI mixed up, whichever one it is.
yeah.
But when you're looking at Lime, it actually shows how decisions are made based off of two features. And so, like I
Mm.
created a classifier that looks for angry Trump tweets. I'm curious about who he's pissed off at. Sorry, my link. I'm curious about who he's angry at that day. So I made a classifier for it.
That's awesome.
And and holy crap, my mind just went blank. What was I saying right before that?
Yeah, well, you were talking about using, like, if you have a ton of columns and there's fewer of
Oh,
them,
yeah.
and the feature selection, what's important.
So
Yeah.
yeah, so Lime will show me. So I use topic modeling all the time because I do really well with topic modeling, and especially with short Twitter tweets. Um, Topic modeling just works very, 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 very well for some reason. Um, and so I just use it. And so, like with the Trump tweet example, it'll be classified as a hostile tweet because topic 7 is above this threshold, which is a negative topic if you actually look into it, and topic 1 is below this threshold, which is a very positive topic if you look into it. And so the less features that you have, the more insights that you're able to very quickly get as well. This was also very useful. I wrote a spam classifier just for fun one time using a very old spam data set, and the two patterns, or the way that spam classification actually revealed itself was that this topic had a high score or these two topics had very high scores. And when it comes to phishing or social engineering, the way that you get somebody is you give them an offer that's too good to be true, and you put a time limit on it. And so
Mm,
if I wanted to steal your money, I would send you a malicious link, and say, I'm giving away, I'm sick of having so much money. I'm giving away $100,000 to the first 10 people who click on this link, but you need to do it in the next 7 minutes. You know, you've got that insane amount of money that kind of messes with the risk management in your head
yeah.
that allows you to take heightened risk, but it also has that time element that's like, oh crap, 7 minutes, I have to get this done. And so NLP very quickly found that pattern, and Lime
Yeah.
brought it to life. So
The probably like an optimistic, like highly positive message followed by something time related, right? Is that what you're talking about? Like those sorts of topics that it's finding, or was the features a little bit different?
well, so like social engineering is just the art of manipulation. It's about
Right.
getting what you want, and so you'll use some kind of incentive. And so I'm giving away a car, or I'm giving your
Right.
child can go to college for free, or whatever. And so it's some big reward and some very tight time limit. And so when you put those things together, you've got a good social engineering attack. And so then you just spam that to everybody in the world, and 1,000 people will fall for it. So
Yeah, I remember one of the places I worked, we had some company, I'm forgetting the name, but they would periodically send, simulated spear fishing attacks, right? And so I remember getting one of those in my email that basically appeared as if it was coming from my boss, essentially. And I don't know if they knew his calendar or something, but he was away at a conference. And I got a message that, hey, I'm out of the office right now. I got to get this gift card to this person. Can you order it and send me this thing, right? In the next hour or something like that, right? Like highly specific. Usually they don't have access to the calendar, so you start thinking, well, all these things line up, and I
Yep.
guess if you're spamming this out to enough people, that's going to be true of 1% of the population that you send it out to, right? So law of large numbers starts working in your favor. Uh, yeah,
Yeah.
it's kind of incredible
Yeah.
how text can work with your brain to do bad things.
And so like this is, I mean, this is part of why like domain knowledge is so important to data science. Like my background is very heavy into cybersecurity. Um, so I've been doing that for a very long time, and I love reading on social engineering. And I used to be very much into pen testing, penetration testing,
Mm.
and so security is always going to be like one of my top passions. And one of the reasons why I jumped into data science is that ideas that I had 12 years ago, I finally have the tools to actually do something about my old ideas. For instance, I had an idea 10, 12 years ago, something like that, to be able to authenticate a user by how they type, the keystroke speeds between different keystrokes, and so if you ever broke this hand, but you didn't break this hand, you're going to have a different dynamic with how you type. Or if you are just not good at typing, you're going to type like this, and you're going to have a very different characteristic for how you type compared to somebody else. And so when you're able to measure the speed delays between individual keys, that's perfect for ML. You could authenticate between a person just off of their typing characteristics. It's the
Yeah.
same as you could authenticate with a person by how they look. And even going back to Alice in Wonderland, I did a little experiment. I forget the actual name of this in linguistics, but it's the comparison between two different people. And so this goes back to my security. I always use like Alice in Wonderland and things like that and fun stuff because I don't want to deal with negative stuff all day. But this is a very serious application. It's being able to tell the difference between two people by word choice. And so that has application in deep fakes, for instance. Let's say that
Oh.
I made a deep fake of you tomorrow. There's multiple approaches to manipulating people, and so with like deep fakes, if let's pretend you were the president or something like that, if I wanted to impersonate you, um, and I wanted to do it in a way that was unbreakable, I would actually have to talk exactly like you. I would have to use your exact word choice. Like I can't pretend to be you because I read different books and I grew up in a different place than you. And I don't even know what my accent is. People have told me that I've got this weird accent because I grew up in Japan around Americans from all over America. And so I'll say pop and soda and Coke and whatever, and
Yeah.
I'm just this weird mishmash of a whole bunch of things. So maybe I'm like yeah,
You
I might,
don't do you have you come across Bubbler
no.
as drinking fountain? Okay, I went to school up at Michigan Tech, way up in the Upper Peninsula, and it was totally new to me that there was a whole bunch of people who came to that university from Wisconsin, and they described drinking fountains, as I call them, as bubblers.
What?
Yeah, and that was just like that blew my mind. Like I can understand pop versus soda and all of that. Like those things I knew what they were talking about, but
Yeah.
bubbler being the name for a drinking fountain just yeah,
What
it
was
was
that?
out there. So,
What was that Liam Neeson movie where his daughter gets kidnapped and he travels?
oh, taken?
Yeah, and so like he works with all these smart guys and they're able to identify where she is in the world based off of word choice they use. Like they said the word for sugar and they recognize that she's in this country, you know, and so that's kind of like what I'm talking about. I could show you the notebook, but it's not much to look at because it's just a classification outcome. But I compared between Alice in Wonderland and Lewis Carroll's Alice in Wonderland and Jane Austen's Pride and Prejudice, and they both have very distinct word usage because Lewis Carroll is much more of a fantasy type writer, and Jane Austen is Jane Austen, you know. And so the model was able to actually tell the difference between the two of them with like 95% accuracy with very, very little data, you know. And it just like I didn't pursue it very far. I just wanted to see if it could be done, but it did work very well. And it shows that you can tell the difference between two people by word choice, you know. And so that can potentially be like a component for a deep fake defense. Let's say that you're trying to do a deep fake attack of a politician. Real-time deepfake defense is difficult because you can't, like, you would have to in real time grab all the text from the real person and build a classifier for that real person and compare it against the deepfake, you know. But if it's presidents and politicians and generals and things like that, we can start compiling these data sets well in advance and building these classifiers well in advance, you know.
Yeah, and who knows, maybe you end up making a model for their speechwriter as opposed to them, so you'll know when they go off script or not.
Yeah.
Because maybe they start changing their word choice, or I don't know if you get into the actual raw audio, vocal inflections or something. I don't know. That's interesting.
Yeah. So with deep fakes, I mean, there's multiple things you can look at. You can look at the word choice alone. I mean, you want to do it in a set of components. You know, you want to look at the video to see if the video's been manipulated. You want to look at the audio if the audio's been manipulated, and you want to look at the text to see if that's actually practical for that person. You know, and I mean, right there, that's a mini framework for deep fake defense. You know, 3 things to look at, and I'm sure there's more you can do. So
Yeah. Oh,
you know,
that's so cool. Just we've reached well over an hour, and I have no idea how much time you have,
oh
but these are such interesting topics. I think, I mean, I could keep talking about this stuff with you for hours, but maybe we should do another one of these times and pick one of the topics that we sort of circled on here. And I don't know, maybe I'll take some of the transcripts from this and apply the NLP that we were talking about and see if I can separate out when I was talking versus you talking by word choice and all of that. Because
yeah.
I don't know, there's all kinds of cool applications that we talked about here.
I'm definitely happy to talk with anybody, to do another one of these anytime. I love collaborating with people. I've worked with a few people on LinkedIn that I've just met over the years, and you know, validated that their models worked, or I helped one person clean up their data set. So I'm just always happy to help other people with personal projects and exploration and things like that.
Yeah. Well, anything that we missed talking about that you want to make sure that we covered? Any parting shots?
No, I would just say, you know, for the next generation, don't be intimidated. Don't be afraid of anything. Just chase your curiosity always. Don't be afraid of the naysayers. You're going to face a lot of negative people no matter what. The people that tell you that something is impossible, just utterly disregard them, because they're typically wrong. If you think that you have an idea that you can do, just do it. Don't care what anybody says. Just chase it. And if you find out that it actually is impossible, then you learned a mountain of information doing it. So,
Yeah.
yeah. And
Love
if you
that.
feel free to reach out to me if you have any questions or anything.
That's awesome. Thank you so much. I'm going to ask if you can hang on for just a moment. I'm going to end the broadcast and like to chat real quick afterwards. So,
Okay, cool.
for all the people who've joined us on this live stream, thank you so much. Really appreciate all the comments that came through. We didn't get a chance to put all of them on there, but we love that sort of engagement. It helps us address relatable things and connect with you guys. So, thank you so much, and until next time,
Cool. Thank you.
take care.